Hello everyone, my name is Manideep. I am from CSC AML section B. Today I am going to say about transformation of star delta and delta star configuration illustrated with real world example. Enhancing network reliability, transformations of star delta and delta star configuration illustrated with real world examples. Star delta transformation, also known as a Y delta transformation, the connections between three phase elements change from a star configuration to delta configuration or vice versa. The transformation is often used in power systems where motors need to be started with reduced voltage to limit the inrush current. The star delta transformation allows for a gradual increase in voltage during the startup of the motor. Delta star transformation. Conversely, the delta star transformation involves changing connections from a delta configuration to a star configuration or vice versa. This transformation is used in power distribution systems to convert a load from a delta connected load to a star connected load or vice versa. It can be necessary based on the requirements of the connected equipment. Some examples from the real world are: consider an industrial facility with motors that need to be started with reduced voltage to avoid a sudden surge of current. The star delta transformation is employed in the motor control system. During starting phase, the motor is initially connected in a star configuration, reducing the voltage across each winding. Once the motor reaches a certain speed, the connection are switched to a delta configuration for normal operation. In power distribution, the delta star transformation might be used in a substation to connect loads that require different configurations to the same power supply. These transformations are practical solutions in electrical engineering to optimize the performance and efficiency of power systems based on the specific requirements of connected equipment. In this presentation, we will explore the transformations of star delta and delta star configurations and their impact on network reliability. Real world examples will be used to illustrate the concepts and benefits of those transformations. Understanding star delta configuration. The star delta configuration is a method of used to reduce starting current in large motors. It involves connecting the motor in a star configuration during starting and then switching to a delta configuration during operation. Benefits of delta star transformation. The delta star transformation is used to transfer a delta connected load into a star connected load. This transformation can help improve network reliability by balancing phase currents and reducing neutral currents. Real world example like industrial motor. In a real world example of the star delta transformation is the starting of large industrial motors by initially connecting the motor in a star configuration. The starting current can be reduced, minimizing stress on the electrical network. Real world example, tower distribution. In power distribution systems, the delta star transformation is commonly used to balance loads and reduce neutral currents. This helps improve the overall reliability of the network and reliability overloading of conductors. Enhancing network reliability by understanding and implementing the transformations of star delta and delta star configurations. Organizations can significantly enhance the reliability of their electrical networks. These transformations offer practical solutions to common network challenges. Challenges and considerations. While the transformations offer significant benefits, there are challenges and considerations to be aware of. These include potential voltage imbalances, harmonic generation, and the need for proper protective measures. Case study network upgrade. A case study will demonstrate the successful implementation of star delta and delta star transformations in a network upgrade project. The study will highlight the improvements in reliability and efficiency achieved through these transformations. Best practices for implementation. To ensure successful implementation, it is important to follow best practices. These include thorough analysis of the network, proper selection of equipment, adherence to industry standards, and regular maintenance and monitoring. Measuring the impact. Measuring the impact of the transformation is essential. Key performance indicators such as reduced downtime, improved power quality, and energy savings can be used to quantify the benefits of implementing star delta and delta star configurations. Future trends and innovations. Looking ahead, future trends and innovations in network transformation will continue to drive improvements in reliability and efficiency. Advan- Advancements in digital technologies, predictive maintenance, and smart grid solutions will shape the future of electrical networks. Imagine a scenario where a factory receives power in a delta configuration, but its equipment is designed to operate in a star configuration. A delta star transformer can be used at the entry point of the factory to transform the incoming delta configured power into a star configuration suitable for the equipment. In summary, these transformations are practical solutions in electrical engineering to adapt the electrical configuration of a system to meet the requirements of specific components or applications. They are commonly employed in various industrial settings to optimize power distributions and the operation of electrical devices. Consider a three-phase induction motor. During startup, the motor may experience high inrush currents that can be damaging. To mitigate this, a start delta starter is commonly employed. In the starting condition, the motor windings are connected in a star configuration to reduce the initial current. Once the motor reaches a certain speed, the connection is switched to a delta configuration for normal operation. Conclusion. In conclusion, the transformation of star delta and delta star configurations offer practical solutions for enhancing network readability. Real world examples and case studies have demonstrated the significant benefits of implementing these transformations in electrical networks. Thank you.